Students. Back. It's live already. Hello P5. Welcome to our online class. This is our second meeting. So today we're going to study about pitch and frequency. Okay, so while waiting for the others, please call your classmate and send them message to join us. We're waiting for about 5 minutes before we start with our lesson. Okay, so please, if you have a comments, please write in English. Hi, I don't know what is your name. Okay, Natapol, hello. 5/1, number 35 and 5/6. Hello to our online class at Chokawa. Is it Chokawa? 5/6, number 12, and 5/1, number 6. 5/2, number 21, and Mr. Tirwat. Okay, so hi also. 5/3, number 25. Hello. Who's that? 5/5, number 10. And hello to 5/6, 5/6, 5/2. And hi to 5/6, number 28. Okay, so we are waiting for your classmate to join us. So, how many? So we are 23 viewers right now. So in 5 minutes, we can start about our topic. It's all about pitch and frequency. And I prepared also our just a short review for our last topic. Do you remember our last topic? P5, do you remember? Okay, it's all about what? What we are topic last meeting is all about the sources of sound, right? Okay, so when can sound travel without medium? So do you remember that? Medium is like solid, liquid, and gas. Today, we're going to study about pitch and frequency. So what is the pitch and frequency? So today, we will have just a short demonstration. What is the difference between pitch and frequency? Sound. What's that? Okay, so welcome. 5/3, number 10. Please, I encourage you to comment in English so that I acknowledge your answer. Or after this video, I'm going to review this video, our live video, because I'm going to check who are participating, who are give the best answer. Okay, so hi to 5/5, number 27. Okay, trail builder. 5/1, number 38. And who's that? 5/4, number 29. And we have also our 5/7, number 5. Welcome to our online class. 5/5, number 26. 5/1, number. And shall we start off? Okay, we can start. It's 5 minutes, although we have 58 viewers. Okay, so while waiting for your classmate to join us, yes, sure. Okay, welcome back. How many are we now? Okay, 73. Okay, just sorry for just a little bit. There's something confusion right there. Okay, to make it clear. Okay, so we're gonna start now. We're waiting for the 100 plus, like 120 students. Okay, so today we will have a short review first before we start with our proper lesson. So welcome 5/1, 5/2, 5/3, 5/4, 5/5. 5/6, 5/7, and 5/8. So this is your science class, and I am teacher Nimpa. Okay, let's see if you remember our topic last week. Okay, this is our past topic. So, number one, please write your answer. Comment your answer there. So, number one is the lowest part of the wave is called the blank. A, crest, B, true, C, amplitude, or D, the wavelength. Okay, the lowest part of the wave. Lowest. The lowest part of the wave. What do you call that? Okay, what is your answer? Wow, the correct answer is letter B. Very good. Wow, everybody get the correct answer. Who answered letter C? Okay. Next number two. Number two, the blank is described as the distance between the crest and through to another crest too. So distance, the distance between. Okay, A, B, C, or D? What is your answer? What is the answer here? For number two, letter? Okay, what's the first one? 5/1, number 16. Yes. Okay, the first one who answered is letter A. We call it the wavelength. Okay, next number, we have number 3. Number 3 is the highest point of a wave is called blank. Okay, highest point of the wave. Highest, this one, this is the highest point. What do you call that? Crest, amplitude, true, or wavelength? What is the correct answer? Okay, the correct answer is letter A. Wow, who answered letter C? Okay, correct. This is the highest point. Right? Very good. Okay. Wow. So most of you get the correct answer. Very good, class. So you remember our last topic. Okay. How about here in number 4? Sound travels most slowly through which of the following? Iron pool. So iron is a metal, right? Metal. Iron pool. A pool of fresh water in liquid. A block of wood. Or this is a wood, this is the sun. Area of dry air. So dry air is the gas. So in which sound travel slowly, very slowly? Letter? Wow. Yes, very good. Everybody got the correct answer. The correct answer is letter D. Okay. Next number we have here. Let's see. If you know the parts of the wave, so you should know our number 1 question here. Which one has a lower amplitude? Okay, lower amplitude. When you remember the parts of the wave, you should know which is the amplitude here. Okay, which one has a lower amplitude? Is it A or B? What is the correct answer? Lower amplitude. Number 5/6. Why letter D? We don't have letter D here. Okay, either A or B. Okay, the correct answer is letter A. Lower amplitude, right? Do you remember this? Okay, this is the amplitude, and it has letter A has a lower amplitude and letter B has the higher amplitude. Okay, how about here? Which point is a crest? What letter is a crest? We have three letters here represent as crest. Point A. Yes, correct. We have point A. What else? We have, aside from A, we have only A. Okay, so B and H. Whose answer? B is here. B is here. Represent as crest. Okay, so A, E, and H. Very good. Okay, 5/1, number 16. E, A, and H. Okay, we have three answers here. The E and then the H. Okay, the point H. Next, question number 3 for our review, the last review here. Give an example of wavelength. Remember the wavelength, right? It is the distance between the 2 points, right? 2 points. The distance between 2 points. Okay. That's this one. Oh, where is the wavelength? Can you give me an example of wavelength? What point? What point? We have wavelength. The distance of 2 crests or the 2 truths. Which one here? We have A and E is the wavelength, right? Distance between 2 crests, or E and H is also a wavelength. And if we had Q here, Q and J is also a wavelength. Or C and Q is also a wavelength. So distance between 2 highest point and 2 lowest point. Okay, wow. So many get the correct answer. Very good. Give hands to yourself. Okay, you remember the parts of the wave. So you are so smart. Okay, example of wavelength in the following figure is the distance between light, A and E, or E and H. Okay, can be C, or Q and J. So those are examples of wavelength. Okay, so let's proceed now to our proper topics. Do you know pitch and frequency? Huh? Yes, hello, Pira what? Okay, so pitch and frequency, what is the difference? So we are talking about sound. This is the continuation of sound that we discussed. So last meeting we discussed about the sources of sounds, or sounds can be traveled in a vacuum or not, or can sound travels without medium, right? Okay, but today we are talking about pitch and frequency. That's why I am holding a ruler here, because this is very important for our activity to show to you the difference between the pitch and frequency. Okay, so I have here an illustration for you. This one. So, what is the relation between the length of ruler? Okay, you know the length, it's like short, and when we talk about the length, meaning short or long, right? Short or long, our length of ruler, the frequency and pitch of the sound produced. So thus, it has an effect between frequency and pitch depends on the length of the ruler. Okay, so Required is 30 centimeter plastic ruler, but I have here metal ruler. 30 centimeter. So this is 30 centimeter ruler, 1 foot long. Okay? 30 centimeter. So the first here, if you had, okay, so if you had ruler, plastic ruler, or metal roller, it's better that you also do it in your home. Okay, are you ready? Okay, how to chat? What's that? I have. Very good. Who's that? 5/3, number 10. God. I had 30 centimeter ruler. Very good. Okay, short sounds. Yes, what's that? 5/6, number 12. Okay, so you don't have, okay, if you don't have ruler, I have a ruler here. So listen carefully so that you know you have an idea about pitch and frequency. Okay, so the first procedure is hold 5 centimeter. Oh, do you know where is the centimeter of the ruler, right? So the centimeter here is one. The smallest, this part. Okay, so the lower part, that is inches. Okay, so this is inches and this is graduated in centimeter, the other part. Okay, so hold 5 centimeter of plastic ruler and firmly on the edge of table. Okay, 5 centimeter. You know, Master, big fan of our video today. It's a sabotage. Okay, so 5 centimeter. Look at the ruler. 5 centimeter. Okay, where is 5 here? This one. You see that? 5 centimeter. It said, hold it firmly at the edge of the table. So this is not a table, this is a box of your milk. So I'm going to use this so that you can see. And then number 2 is push the free end. So this is what we call, class, the free end. Okay, this is the free end of the ruler. And push the free end of the ruler downward and then release. Okay, remember that? 5 centimeter. 5 centimeter. Hold it firmly and then push the free end. Free end of the ruler and do it downward. Release like this. Okay, so if you have that in your home, you can do it like this too. Okay, this is what we call release. Okay, hold it and release. You see the movement of the ruler? It's back and forth, right? Up and down very fast. And that is the example of vibration. Number 2 is listen to the sound produced. Okay, I will ask Master if the sound is loud or not. Okay. I'm sorry.
Oops.
I'm sorry. Okay. Master, can you hear the sound?
No, I can't.
You can? Are you sure? You cannot hear the
It's
sound?
very low.
Very low. Very good, Master. That's the correct answer. Okay. The sound is very low. Very good. Okay. Next. Do it. Number 4. Okay, when the free end of the ruler is pushed downward and then released, it vibrates. It moves up and down. And sound can be heard. And Master said, yes, he heard, but very slowly. In 5 centimeter. So at the edge, meaning it's very long because up to here only, right? So the rest is long. And the next step, number 4. Repeat step 1 to 3 by decreasing the length of free end of the ruler to 10 centimeter. Okay. Decrease meaning we're going to reduce the length of the ruler at 10 centimeter. Okay, it seems like this. Where is the 10 here? Okay, so we use the 5 and now 10. I will hold it very firmly And then the same thing, push it downward and release. Okay. Master, do you hear the sound?
Yes.
Yes. So what's the difference between the long and short? Which is louder?
This one is louder.
Ah, the short one is louder. You are correct. Very good, Master. Okay, yes, correct. Okay, so observe both vibration fill in the table below. Okay, let's fill in the table here. So free end of the ruler. So the long here represents as 5 centimeter because we use the 5 centimeter. This one. So long end, right? And then for the short is we use the 10 centimeter. So let's analyze and answer. Just tell me higher or low, high or low only. So vibration, fast or slow, in low. So do you remember? This is 5. Okay, this is 5. And this is 10. Okay, so vibration meaning move back and forth. How fast or slow between the long and short, which length has a fast vibration and which length has a slow vibration. Can you tell? Can you tell that? Which one? In long or in short? Fast vibration. Is it in long or short? Wow, short. Who's that? Very good. 5 / 6, number 12. Okay. And of course, the short vibration is in slow and short is very fast vibration. Thank you, Master, for assisting me. Okay, you say thank you to Master B. Okay, then next is frequency. Is it high or low? So frequency, but we cannot able to answer this because we don't know what is frequency, right? So what is frequency? We know already the vibration, the movement of ruler, right? The movement of back and forth. So frequency, is it high or low? Pitch, either low or high. So how can we able to answer this? Okay, so I'll give you an answer, but we have to prove this for frequency class in a long edge. The frequency is low. Okay, in short, the frequency is higher. The pitch meaning low in long and in short is it higher. So how? So meaning how this pitch and frequency is related to each other. Okay. So to be able to answer that, let's proceed to number 6. So did the ruler vibrate fast when the free end of the ruler is short? Did the ruler vibrate fast? Just answer me yes or no. Type your answer because I'm going to review to those comments there. And if you get the correct answer, you have up points. Okay, very good. Who's that? 5 / 6, number 12. The answer is yes. Okay, in a short, it is very fast. Number 7 question is the frequency high when the vibration is fast? Why is it is so? So I'll give you already the answer for that, right? Okay, so the frequency is high when the vibration is fast. Yes. And why is it? So the answer here, yes, because the short length vibrates more quickly, like this, right? If it is short, it vibrates more quickly than the longer length, right? Okay, for number 8, based on your observation, when the frequency of the vibration is high, does the sound produce a high pitch? Does it have? What do you think? In our data, what do you think? It is a high? Okay, so the answer here is faster. Oi, please comment in English. Okay, faster, faster. Just answer yes or no. I think not. Okay, so the answer here is okay. If your answer is yes or no, okay, I'll give you that. So I'll give you that point because you don't have any idea at all. So later you will find out why. Okay, for number 8, the answer is yes. Okay, so next number 9. So how the frequency of sound relate to its pitch? Do you remember the graph? Do you remember the table? The short and long length. And long, it has what? Have fast. This is low, and then this is faster. The sound produced in long is low, while the sound produced in short is fast. Right? In short, short length, high pitch, and then in long, if it is long, meaning the pitch is lower, right? Low sound. Okay, so how the frequency of a sound relate to its pitch? Okay, so who is? Okay, who can answer that? You don't see the ruler? Okay, so number 9 questions. I'm going to demonstrate again. Okay, so in short length, the sound is loud. Okay, and then the vibration is fast. Therefore, if the sound is loud, the pitch also high pitch. If the length is long, okay, the sound produced is low. So therefore, the pitch is also low and the frequency is also low. Understand? So how the frequency of sound relate to its pitch? So meaning, what is the difference to them? How do they relate each other? And okay, the long of the ruler. Okay, so the long it is, what's that? The long it is long, the more sound and low sound. Okay, so here is the correct answer. Sound with high pitch have high frequency. Okay, high frequency. So that is the same. Okay, and then sound with high pitch, because pitch is the how long or short the sound. If it is high pitch, the frequency also is high. When sounds with low pitch have a low frequency also. Okay? Okay. Then we have here the pitch and sound. Okay, listen carefully so that you will understand how the sound and frequency relate each other. Okay, why? If the pitch is low, the sound is also low, the frequency is also low. When the pitch is higher, the frequency is higher, and the sound is also higher. So the pitch of sounds is how high or low. So this is the meaning. Pitch is shows it's a sound. It shows how high or low the sound. So lower pitch has a lower amplitude. Higher pitch has a higher amplitude. So remember the amplitude class in parts of the wave, right? Okay, so this is the center line, and this is, okay, we have two waves here. Change to yellows. Yellows. Okay, let's change to yellow. Thank you, Master. Okay, so this is our center line, right? Okay, so low amplitude, low pitch. Example, this is now our wave. Okay, so this is low amplitude compared to the sound. Okay, so if the amplitude is low, meaning that is the height of the wave. Do you remember that? The height of the wave. So height of the wave is what we call the amplitude. So if the amplitude is lower like this, so meaning the pitch also is lower. Remember the pitch? High or low sound. Low amplitude, low sound. Understand? And if the pitch is higher, so meaning the amplitude also, the height of the wave is also high. Like this. So this is the amplitude, the height of the wave. So this is figure A and figure B. So in A, lower. In B, higher. High amplitude, high pitch. Lower amplitude, low pitch. So meaning pitch, it shows how high and low the sound is. Okay, understand now so that we can proceed to next. Next is frequency. So what is frequency? This is the number of waves that pass fixed point in a unit time. So it is measured in seconds. For example, this is 1 second. So this is frequency, for example, class. Frequency, can you count the number of waves here? Okay, who can count the number of waves? For figure A, how many wavelengths? How many? We have 2, right? We had 2 wavelengths. Okay, so in frequency class, this is the number of waves in 1 second, in one measurement. Supposing this is 1 minute and this is also 1 second and this is 1 second. How many waves in 1 second? So in figure A, like for example, we made 3 waves, right? So there are 3 waves in 1 second. In figure B, we have how many waves? 1, 2, 3, 4. We have 4 waves. 4 waves in figure B, right? So frequency is the number of waves per second. Understand? That is high frequency wave makes a high pitch. So meaning high frequency, the more wave in one measurement, that is high pitch. This is high pitch, and this is low pitch. Get it? Low pitch meaning low sound. So low sound, and this is high sound. Okay, so what else? High frequency wave makes a high pitch sound. Low frequency wave makes a low pitch sound. So meaning when we talk about frequency, that is the number of waves in 1 second. So in 1 second, if there's more than waves, like for example in figure A and B, if we compare, this is higher, a higher pitch, meaning what is a pitch? Higher pitch sound, high sound, and this is low sound because the number of waves compared to B is less than. Understand? Okay, so next. Next is frequency. Okay, frequency is the number of vibrations in a second, and we measure it hertz. Okay, the unit of frequency is hertz. Like for example, this is what we call frequency is the number of vibration in 1 second, like this. If you can count the number of vibration, meaning back and forth of ruler, like moving up and down like this, can you count the number of vibration in a second? It's hard to count, right? Because it's very fast, right? Oh, see, it's really fast. So that is frequency. Number of vibrations or number of waves in a second. So the unit of frequency is hertz. So like this, okay? In 1 hertz in 1 second. So this is second class. Look at this. So which one here is, let's change the color. Figure A and figure B. Which one here is low pitch? This is 1 hertz and this is 10 hertz. Okay, can you count the number of waves in figure B and figure A? How many waves? How many waves in figure 1? Figure A. How many waves? How many waves in figure A? Is it 2? Yes. 5 / 6, number 12. Yes, you are right. Okay, this is 1 wave, right? 1. Okay, so 1 hertz. In 1 second, 1 wave. Compared to figure B, how can you describe the pitch here? In figure A, how can you describe? It is high or low? The pitch, high or low? What is that letter A? In figure A, how can you describe? Describe the pitch in figure A. Is it high or low compared to letter B? Figure B. Very good. Who got the first answer here? I can't read it. Yes, this is low. Okay, this is low. Low pitch, low sound. Right? But here in figure B, how many waves? You count the waves here. I think you count it already. Let's start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 waves in 1 second, right? 10 waves in 1 second. So therefore, this is higher than figure B. So if we're going to compare the sound produced between A and B, of course, letter B has a high pitch, right? Okay, high sound. And the frequency also here is high, right? Pitch is high, and then compared to figure A. Okay, so always remember that frequency, the unit is hertz. That is very important. When we're talking about hertz, meaning meaning number of waves in 1 second. Okay, so can you summarize now our topic? What is the difference between frequency and pitch? Okay, let me see. I'll give you 1 point. Don't forget, I'm going to review your answer. Okay, what is the difference between pitch and frequency? What is pitch and what is frequency? He said, Teacher Nimpa, I think 20 hertz people can hear. Very good, because audible is 10 hertz to 20,000 hertz. Very good, who's that? 5/2 number 16. Yes, you are right. Okay. What is the difference? Give me the meaning of frequency and pitch now, because this is our topic. Pitch is the what's that? What is pitch? Anybody? What is that height? Please write your answer in English. What is height? 5. What's that? High amplitude. Pitch is high amplitude. Yes, correct. Pitch, it depends the height of amplitude. Okay, it depends on the height of amplitude. Yes, because if the amplitude is high, the pitch is also high. If the amplitude is low, the pitch is also low. As again. Okay, difference. So what is frequency and what is pitch? Okay. Frequency is the amount of waves in 1 second. Very good. Pete, I remember you, Pete. Okay. Frequency is the amount of waves in 1 second. Correct. Very good. What else? How about pitch and frequency? What is the difference? What is the difference between pitch and frequency? 5/3 number 10 said frequency is the number of vibration. You are right. Vibration or number of waves is correct. Okay. So vibration, that is the movement like back and forth. And who's that? 5/6 number 38. Pitch is a time of vibration. No, that is the time. That's not a time of vibration. Because when we talk about frequency, we are using, to measure the frequency, we are using the seconds, the time. But pitch, just like high or low. Okay? So, the best answer is the height of amplitude. Okay. Pitch, amplitude, frequency is the height. No. So, amplitude, are they similar? Probably yes, because amplitude, if the amplitude is high, the frequency is also high. Okay, you are right also. Next, we have pitch is how high. Pitch is how high is amplitude. Okay, so it depends. Yes, so amplitude, that is the height. Okay, so you know already the amplitude, right? The height of the waves. Okay, the higher the amplitude, of course, the higher of the sound is. Okay, no more answers. So let's proceed to our eye. So please scan a teacher. It's already scanned. It's already. Okay, can you scan it and answer some questions that I prepared to you? And okay, I'll give you time to scan it first. Oh my God. That's very easy, promise. We did it. If you are if you start our live, so you will able to answer. I prepare only just like 6 questions for you, equivalent to 9 points. Okay, so this is very easy. You can do it perfect without Google search. If you listen to me without Google search, you will able to answer. This is very easy questions. Okay.
Oh, you haven't answered in the question.
Mhm.
You have
Not yet, not yet already.
So you have to, and you have to unlink for the mail.
Đừng có năng có ý tôi được không?
นักเรียนรอสักครู่นะครับเดี๋ยวเรียนแคปหน้าจอไว้ก่อนก็ได้ครับแคปหน้าจอไว้ก่อนนะครับรอสักครู่นะครับใครอยากสแกนหน้าจอสแกนก่อนเลยนะครับ
Okay, are you done scanning? I can't get in. Oh, they can. It say it's no longer accepting. Oh, they can. Master, they can. It will take a while because teachers are doing.
It's okay now.
It's okay now. Okay, so. Three rounds. Okay, finish. Are you done? Are you done scanning?
การทำนักเรียนเข้าไปทำในครั้งเดียวนะครับใครเข้าไปทำครั้งที่สองครั้งที่สามเราจะไม่นับคะแนนเราจะนับคะแนนครั้งแรกดูจากการทำได้น้อยที่สุดแต่ว่าเป็นครั้งแรกนะครับดูจากเวลานะครับมีเวลาระบุด้วยนะครับใครเข้าไปทำหลายครั้งเพื่อให้คะแนนมากขึ้นไม่มีประโยชน์นะครับเราดูจากเวลาที่คุณเข้าครั้งแรกทำครั้งแรกได้คะแนนเท่าไหร่เอาเท่านั้นนะครับ
Okay na. Okay, you've done already. Okay, it's time already. See you on next live streaming. Bye bye. See